Welcome to Science and Engineering World, where we use the principles of mathematics and science to think engineering, act engineering, and practice engineering. In this presentation, we want to use a practical scenario to demonstrate some effects of fluid pressure. My name is Olutola Fakehinde. Surfaces are horizontal, vertical, inclined, and even curved. And fluid always has significant effects when it is in contact with any of the surfaces. We want to examine fluid pressure force on vertical and horizontal surfaces in this presentation. In a serious accident like this, can the driver in this car escape on his own effort? Let's examine this. The scenario here is that a car with a mass of 2,200 kg runs off the road in an accident and lands at the bottom of a lake 6 meters deep. The dimensions of driver's door are 1.2 meter long and 1.1 meter wide. Some 4 pertinent questions come to mind. Before we go into the solution of the problem, I want to encourage you to encourage us by subscribing to this channel. It is very important for us because YouTube uses some algorithms which includes the subscription, the liking of the video, the sharing of the video, and commenting in the comment section of the video. And we appreciate you for doing all of this. For those who have subscribed already, thank you. For those who are yet to subscribe, there is a red button at the bottom right corner of your screen. Please press it. Press it now before we proceed to solving the problem. And at the same time, there is a bell. Press that for notification so that you can see as we drop videos from time to time. Thank you for doing this. We have treated in details question 1 in part 1, and so in part 2 we want to look at the question 2. However, I will encourage us to watch part 1 because some conditions, some assumptions, some definitions we have done in part 1 are going to be useful here in part 2. I won't be able to go back to that, but we'll just do a little recap here. We saw the car at the bottom of the lake and we're able to look at the door and analyze the forces acting on the door. And we saw here that the force from the water was 77 kilonewton approximately, 77 kilonewton, and the driver was applying his own force on that side, which is 1 kilonewton. And from there we were able to conclude that it was not possible for the driver to escape from the car at this particular point. And so we now want to look at the car, the door of the car at the level of the water. So welcome to part 2, where the question is, since he cannot escape in part 1, is it possible for him to escape now with the door of the car at the level of the water? Let's look at this analysis together again. Now in this second question, we now see that the top of the door is at the same level of the water, and we say that the door itself is D, the length is D, which is 1.2, and so the H bar will be half of the length, that is H bar will be 0.6 meters. Because they have the same level, so the center of the gravity to the top of the level of the water is 0.6. So H bar equals to 0.6 meters. The area of the door has not changed, so area will give us 1.32, like we had before, meters squared. The configuration of the door has not changed, it's still a rectangle, so IG is still the same as 0.1584 meter to power 4. The expression for the center of pressure is still the same thing, and it is HCP equals to H bar plus IG over H bar. So let's substitute these values in our HCP. So substituting the values into HCP, we have HCP will be equal to 0.6 for the H bar plus 0.1584 for IG. Area is 1.32 times H bar, which is 0.6. So if you put all of this in the calculator, we have 0.6 here plus 0.2. Therefore, HCP, that's the center of pressure, HCP is equal to 0.8 meters. The result is interesting because it validates one point, and that point is that when you have a rectangle that is immersed vertically in water, its center of pressure, HCP, is equal to 2/3 of its height, which is D here. So 2/3 of D is equal to, that is HCP equals to 2/3 times 1.2, which is giving us the same thing as 0.8. So it shows that we are in order. So the center of pressure is 0.8 from the top of the water. Now we want to find the force exerted by the water on the door. And remember, we used FTW to be equal to gamma H bar, which is the pressure, times the area. Gamma, we said, is the specific weight of the water, and that is equal to 10,006.2 Newton per meter cube. And then H bar is now 0.6 meter, and area is still the same. Area is 1.32 meter square. Okay, so now we now put these values in the expression for FTW. So FTW will be equal to 10,006.2 times 0.6 for the H bar, and then the area 1.32. Okay, by the time we put all of this in our calculator, we see that this is equal to 7,924.91. The unit, we have gamma, which is specific weight, is Newton per meter cube, times H bar, which is meter, over 1, times area, which is meter squared, over 1. So here, meter times meter squared is meter cube. So this, we cancel all of that, and so we have Newton. So this figure is in Newton. Writing it in scientific notation, we then have that FTW is approximately equal to 8 kilonewton. Okay, so we now have here 8 kilonewton on the water side, 8 kilonewton on the water side, and then the driver is exerting his own 1 kilonewton. With this, we can conclude that the driver can still not push the door open, and he cannot escape unless there is an external force upon the door. Let's take a break here, and then when we come back, we'll be able to look at the other 2 questions. Again, it is impossible for the driver to escape at this point without someone to rescue him from the car. The question now is, can he possibly escape? In part 3, we shall go further to examine a point where he can escape. I will put the link to part 3 at the top here and in the description section below for you all to examine that point. It will be interesting to find out that he can still escape. Alright, If you enjoy what we have done and you find this video very useful, do 3 things for me as usual. Number 1, like the video. 2, share with others. Make comments. We want to hear from you. Any question, any concerns, put them in the comment section below. And lastly, I always encourage, please subscribe to this channel. Your subscription will take us to other parts of the world, and if you have not subscribed, there is a button here below, very at the bottom right here below, and I would like you to do that now. And like I always encourage, think, act, and practice engineering. Until we meet in part 3, keep studying.